The legality of 480 volts fluorescent lighting indoors depends on the specific circumstances of the installation. Article 210.6c prohibits conductors exceeding 277 volts nominal to ground from being installed in dwellings and other specified locations. It defines voltage to ground as the greatest voltage between a given conductor and any other conductor of the circuit. In a case of a 480-volt circuit with no neutral conductor, there is no other conductor in the circuit relative to which the voltage can be measured. Therefore, a circuit is not an ungrounded circuit as defined in Article 100. Article 210.6d prohibits conductors exceeding 277 volts nominal from being installed within 10 feet of the floor unless in metal raceways or enclosed cables. Since a 480-volt circuit is not an ungrounded circuit under Article 210.6c, Article 210.6d does not apply. In conclusion, the strict interpretation of the code prohibits 480 volts fluorescent light indoors, as it exceeds 277 volts nominal to ground. However, the following factors may suggest that the code does not intend to outright prohibit this type of installation. Firstly, in practice, 480 volts lighting is commonly used in industrial settings, often at elevations exceeding 10 feet. Secondly, electricians often rely on the grounding of conduits to provide a safe path for fault currents, even though raceways are not explicitly defined as part of the electrical circuit. The recommendation is to consult with the local electrical inspector or other qualified authority to determine the acceptability of 480 volts fluorescent lighting in the specific installation. Another recommendation is to use metal raceways or enclosed cables for the installation to minimize the risk of shock hazards. Also, install the lighting at an appropriate elevation to ensure compliance with Article 210.6d. The key to understanding this lies in the definition of voltage to ground and whether a 480-volt circuit without a neutral can be considered an ungrounded circuit within the meaning of the National Electrical Code. It is also critical to understand that electrical codes are subject to interpretation by local authorities, so it is always recommended that a local inspector be contacted to ensure compliance. The NEC, or National Electrical Code, is a set of standards that are established to ensure safety when it comes to electrical installations. The NEC is revised on a 3-year cycle. It's important to consult the latest version of the NEC and any local amendments or ordinances in your jurisdiction. Article 100 of the NEC provides definitions for terms used throughout the code. The definition of voltage to ground is crucial here. For grounded circuits, it is the voltage between a given conductor and the grounded circuit conductor. For ungrounded circuits, it is the greatest voltage between the given conductor and any other conductor of the circuit. Article 210 covers branch circuits, which are the circuits that supply power to outlets and lighting fixtures. Section 210.6 specifically addresses limitations on voltage in branch circuits. As the question states, 210.6c limits the voltage to ground to 277 volts in certain occupancies. 210.6d prohibits voltages exceeding 277 volts between conductors in specific situations, such as within 10 feet of the floor. In a 480-volt circuit with no neutral, the voltage between any two conductors is 480 volts. However, the voltage to ground is a point of interpretation. If one argues that the conduit or equipment grounding conductor serves as a reference to ground, then the voltage to ground would be approximately 277 volts in a 480 volts Y system. However, if the circuit is truly ungrounded, with no intentional connection to ground, the voltage to ground is technically undefined or considered to be the phase-to-phase voltage, in this case 480 volts. The grounding of the conduit is primarily for safety purposes, specifically to provide a low impedance path for fault current to return to the source, thereby tripping the circuit breaker or fuse and clearing the fault. It's a safety measure to protect against shock hazards, but it doesn't necessarily define the circuit as a grounded circuit in the sense of voltage to ground. The code's intention regarding 480 volts lighting indoors is somewhat ambiguous. While a strict interpretation of 210.6 might suggest a prohibition, the common practice in industrial settings indicates otherwise. It's not uncommon to see 480 volts lighting in factories, warehouses, and other industrial environments, especially at higher mounting heights. This is because 480 volt systems are more efficient for distributing power over long distances and for supplying high power loads. In these cases, several safety measures are usually implemented, including the use of metal raceways, proper grounding, and high mounting heights to minimize the risk of contact. A too literal reading of the code could lead to unnecessary restrictions and increased costs, especially in situations where 480 volts lighting is a practical and safe solution. However, safety should always be the primary concern, and any installation must comply with the intent of the code, which is to minimize the risk of electrical shock and fire. Firstly, consult with the local electrical inspector or authority having jurisdiction (OJ). They have the final say in interpreting and enforcing the code. Secondly, review the specific requirements of the project and the occupancy. Consider the mounting height of the lighting fixtures, the type of luminaires, and the presence of any conductive materials or equipment that could pose a shock hazard. Thirdly, ensure that all wiring and equipment are properly grounded. Use metal raceways and grounding conductors to provide a low impedance path for fault current. Fourthly, install ground fault circuit interrupter (GFCI) protection if required by the code or if there is a risk of ground faults. Fifthly, use appropriate signage and warnings to alert personnel to the presence of high voltage equipment. When dealing with 480 volt systems, it's essential to follow safe work practices and use appropriate personal protective equipment (PPE). This includes wearing insulated gloves, safety glasses, and arc-rated clothing. It's also important to de-energize and lock out the circuit before working on any electrical equipment. In addition to the NEC, other standards and regulations may apply to lighting installations, such as those related to energy efficiency, light levels, and emergency lighting. Be sure to comply with all applicable requirements. It is important to understand what is meant by voltage to ground. In a grounded system, like a 480 volts Y system, the neutral conductor is connected to ground at the service entrance. This creates a reference point, and the voltage from any phase conductor to ground is approximately 277 volts. However, in an ungrounded system, there is no intentional connection to ground. The voltage to ground is not fixed and can vary depending on the impedance of the circuit and any unintentional connections to ground. In this case, the voltage to ground is often considered to be the phase-to-phase voltage, which is 480 volts. The question raises a valid point about whether the grounding of the conduit affects the voltage to ground. The conduit is grounded to provide a safe path for fault current, but it doesn't necessarily define the circuit as a grounded circuit in the sense of voltage to ground. The code does not explicitly define the conduit as part of the circuit, but it is an integral part of the electrical system and plays a crucial role in safety. The fact that the conduit is grounded provides a degree of safety, but it doesn't change the fundamental nature of the circuit as either grounded or ungrounded. The use of 480 volts lighting in industrial settings is often justified by the increased efficiency and reduced voltage drop compared to lower voltage systems. However, it also requires a higher level of safety awareness and adherence to code requirements. It's important to consider the potential risks and implement appropriate safety measures to protect personnel and property. Article 210.6 of the National Electrical Code (NEC) addresses voltage limitations. Understanding this article is crucial for determining the legality of 480 volts lighting indoors. Article 210.6 generally limits the voltage to 120 volts between conductors that supply terminals of luminaires, with some exceptions. This section is typically not relevant for 480 volts lighting systems, which are not designed to supply 120 volts to the terminals of luminaires. Article 210.6c addresses voltage to ground. It states that the voltage to ground on branch circuits shall not exceed 277 volts in dwelling units and guest rooms of hotels, motels, and similar occupancies. This section also applies to other specified locations, but it is less likely to be applicable in an industrial workroom. The key here is the definition of voltage to ground, which, as mentioned earlier, can be interpreted differently for grounded and ungrounded systems. Article 210.6d addresses voltage between conductors. It states that the voltage between conductors on branch circuits shall not exceed 277 volts, nominal, to ground in occupancies other than dwelling units and guest rooms. However, there are exceptions, such as for permanently connected utilization equipment. This section is more likely to be relevant for 480 volts lighting systems, as it directly addresses the voltage between conductors. The exception for permanently connected utilization equipment may apply if the lighting fixtures are considered to be permanently connected. To determine whether the exception applies, it's necessary to consider the specific characteristics of the lighting fixtures and the installation. Are they hardwired, or are they connected with cord and plug? Are they easily removable, or are they intended to be permanently installed? The answers to these questions will help determine whether the lighting fixtures qualify as permanently connected utilization equipment. In addition to Article 210.6, other sections of the NEC may also be relevant for 480 volts lighting systems. For example, Article 410 covers luminaires, lamp holders, and lamps. This article provides requirements for the installation, wiring, and grounding of lighting fixtures. Article 480 covers storage batteries. Although this may not seem directly related to lighting, it's important to consider the power source for the lighting system. If the lighting is powered by a battery backup system, Article 480 may apply. Article 600 covers electric signs and outline lighting. This article may be relevant if the lighting system includes any signage or decorative lighting. Ultimately, the legality of 480 volts lighting indoors depends on a careful analysis of the NEC and any applicable local codes. It's essential to consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable requirements. The strict interpretation of the code might lead to a prohibition of 480 volts lighting indoors, but the common practice in industrial settings and the intent of the code to provide for safe and efficient electrical systems should also be considered. A balanced approach that takes into account both the letter and the spirit of the code is necessary to arrive at a sound decision. The NEC is not intended to be a rigid set of rules that must be followed without exception. It's a set of guidelines that should be applied with common sense and good engineering judgment. The goal is to ensure safety, but also to allow for innovation and the use of new technologies. In the case of 480 volts lighting, it's important to consider the benefits of this type of system, such as increased efficiency and reduced voltage drop. These benefits can lead to significant energy savings and improved performance. However, it's also important to be aware of the potential risks and to take appropriate measures to mitigate those risks. This may include using metal raceways, grounding all equipment, and providing GFCI protection. It's also important to train personnel on the safe operation and maintenance of 480 volts lighting systems. In summary, the legality of 480 volts lighting indoors is a complex issue that requires careful consideration of the NEC local codes and the specific characteristics of the installation. There is no simple answer, and the decision should be based on a balanced approach that takes into account both the letter and the spirit of the code. Consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable requirements. The electrical conduit does not count as part of the electric circuit. In the context of the question, the conduit's primary function is to provide physical protection and a grounding path for the wiring within the electrical system. It's not intended to be a current-carrying conductor under normal operating conditions. The electrical circuit, as defined by the NEC, consists of the conductors that carry electrical current from the source to the load and back. In a typical 480 volts lighting circuit, these conductors would include the phase conductors and, in some cases, a neutral conductor. The conduit, on the other hand, is a metallic or non-metallic enclosure that houses the circuit conductors. It's connected to ground to provide a low impedance path for fault current to return to the source, thereby tripping the circuit breaker or fuse and clearing the fault. This grounding path is essential for safety, as it helps to prevent electrical shock hazards. The conduit is not considered part of the electrical circuit because it doesn't carry current under normal operating conditions. It only carries current during a fault when there is an unintentional connection between a phase conductor and the grounded metal enclosure. During a fault, the current flows through the conduit back to the source, causing the circuit breaker or fuse to trip and to energize the circuit. This prevents the fault from escalating into a more serious hazard, such as an electrical fire or shock. The grounding of the conduit is typically achieved by connecting it to the equipment grounding conductor, which is a separate conductor that runs along with the circuit conductors. The equipment grounding conductor is connected to the grounding electrode system at the service entrance, which provides a direct connection to earth. This grounding system ensures that all metal enclosures and equipment are at the same potential, minimizing the risk of electrical shock. In addition to providing a grounding path, the conduit also provides physical protection for the circuit conductors. It protects them from damage caused by impact, abrasion, moisture, and other environmental factors. The type of conduit used depends on the application and the environment. Metal conduit, such as rigid metal conduit (RNC) or electrical metallic tubing (EMT), is typically used in industrial settings where there is a risk of physical damage. Non-metallic conduit, such as PVC conduit, is often used in corrosive environments where metal conduit would be susceptible to rust or corrosion. The conduit is typically installed in accordance with the NEC and any applicable local codes. The NEC provides detailed requirements for the type of conduit, the size of the conduit, the spacing of supports, and the methods of installation. It's essential to follow these requirements to ensure that the conduit provides adequate protection and grounding for the circuit conductors. While the conduit is not considered part of the electrical circuit in the sense of carrying current under normal operating conditions, it's an integral part of the electrical system and plays a crucial role in safety. The grounding of the conduit provides a low impedance path for fault current, preventing electrical shock hazards and electrical fires. The physical protection provided by the conduit protects the circuit conductors from damage, ensuring the reliability and longevity of the electrical system. The NEC intends to ensure safety and to minimize the risk of electrical shock and fire. It's not intended to be a rigid set of rules that must be followed without exception. The NEC provides a set of guidelines that should be applied with common sense and good engineering judgment. The goal is to ensure safety, but also to allow for innovation and the use of new technologies.